These are the frequently asked questions for pre-calculus for section 3.6 day 1, where we were talking about a lot of the interest formulas. And number 7, it says in exercises 5 through 8, find the amount A accumulated after investing a principal P for T years at an interest rate R compounded K times per year. So there's a lot to keep track of, but what really needs to grab your attention here is how many times per year are we talking about? So the K value is telling us that basically this is monthly. That K is 12. So that means that we're going to have to use the more difficult of the two formulas, and I keep wanting to put N, but your book uses K for KT there. So we want to know how much is in there, that's A, if we put in $40,500, that has an interest rate of 3.8, so 0.038, because we still have to change that into a decimal if we're going to do calculations with it. And that needs to be divided by how many time periods that we're talking about, and we are talking about months, so that means a 12. And then the KT on the outside is really how many of those periods are going to take place. So notice that the T equals 20 tells you that's T years. So for 12 years, for 20 years, we will have 12 of those, which is of course going to give us 240. So that's our power. One of the things I was just thinking about as I'm going through that is maybe you have this as your answer, but you're getting the wrong decimal. So I am going to go ahead and punch this in, and maybe that will help with whatever it was that you had difficulty with. So we'd start thinking innermost parentheses, which would actually be the interest rate there. So 0.038, and then we need to divide that by 12, get an answer. Add 1 to it, get an answer. Raise it to the 240th power, get an answer. And then we need to multiply that by the 40,500. And there's the answer. So $86,496 and approximately 26 cents. Again, any bank would probably round down on that and go to 25, but your book is just rounding. So $86,496.26. Then the next one on your list was 27, which is a pension problem. Jack is an actuary working for a corporate pension fund. He needs to have $14.6 million grown to $22 million in 6 years. What interest rate compounded annually does he need for this investment? So again, you'll notice what I went after right away was how often are we compounding this, because this would be simple interest. Since it is annual, that's what we can do. And we don't need all the zeros because we're finding the interest rate, and those won't necessarily affect what we're going to do with the interest rate. So he wants $22 million, has 14.6, and the time was 6 years. So we get started by first dividing both sides by 14.6. And I'm not even going to bother doing anything with that. And we get to this point and we realize we need to get some access to that little 6 up there. So to do that, we're going to take the natural log of both sides. So the natural log of 22 over 14.6 equals 6 natural log of 1 plus r. Now, what I would do is divide both sides by 6. So far we have the natural log of 22 divided by 14.6. All of that is going to be divided by 6, and that equals the natural log of 1 plus r. But in order to get rid of that ln, I need to think of that as the logarithm base e of 1 plus r, which brings us to the point when we would snail shell this. We would exponentiate it and say e to this power equals this. So e to this really obnoxious power of natural log of 22 divided by 14.6 divided by 6 equals 1 plus r. And then of course once we have this answer for the natural log of 22 divided by 14.6 all divided by 6, we will subtract 1 from it. And that way we can punch this in all at once. And again, what I'm going to do is do this in pieces because you asked for a couple of these, which makes me think that maybe it was getting punched in wrong. So you want to start innermost parentheses there, which would be with the natural log of 22 divided by 14.6. Stop and get an answer. And then we would divide that by 6. And now we need to raise e to that power. So we do second e to the x, and we put answer in there by hitting second and the negative button. And that's going to give us e to that power. And then of course we still have to subtract the 1. And there it is. So 0.0707258905, etc. Which would be approximately 7.073%. So like I said, I thought perhaps it's the punching in that's going wrong for you, and when that happens, just take it step by step, because obviously you're missing a set of parentheses or something that the calculator needs in order to give you the answer. So then, next one up is 28. Bank president. The president of a bank has $18 million in his bank's investment portfolio that he wants to grow to $25 million in 8 years. What interest rate compounded annually does he need for his investment? So again, you might have been doing a little bit of overthinking on these. This is definitely about just annually is simple interest. So that's the only formula you need to use. And we want it to be 25 million, starting at 18 million. And what we're trying to figure out is the interest rate. And what we do know is that he wants it in there in 8 years. So this is very similar to the last problem I just did. We would divide both sides by 18 to gain access to that r. We have to get rid of the 8, so we'll take the natural log of both sides. So the natural log of 25/18 equals 8 natural log of 1 plus r. Divide both sides by 8, so natural log of 25/18 divided by 8 equals natural log of 1 plus r. But just like in the last example, we should really think of this as logarithm base e so that we can snail shell this. So e to this nasty power, e to the natural log of 25 divided by 18 divided by 8 equals 1 plus r. And we're going to punch in the e to the natural log of 25 over 18, all divided by 8, minus 1 to get the r. And again, I will go ahead and punch that in step by step so that we make sure that everything's working out like it should. So let's see, we need the natural log of 25 divided by 18. Then we need to divide that by 8. And then we need to raise e to that power. So second e to the x, second negative for answer, and then we need to subtract 1. So not as high an interest rate for this one as we had for number 27. So 0.041917753, which will be approximately 4.192%. All right, next up, we switch gears. This is complete the table about continuous compounding. and we have an initial investment and we have the time that it takes to double it, and they want to know how much it's going to be in 15 years. So notice there's a question mark in the APR. That's what we have to take care of first. And this was continuously compounding, which means we use the Stinky Green Shampoo formula, APERT. So now what do we know? Well, we know the initial investment was $9,500 and it doubled, so then you'd say, okay, well, what's 9,500 times 2? Well, it's 19,000. So we're going to have $19,000, started with 9,500, don't know the interest rate, but we know that it took 4 years. So now, we would divide both sides by 9,500. And we would see exactly what we talked about in class, which is basically that we could have just skipped right to this. Because if we're going to double it, what we know is that the ratio has to be a 2. And then we would go ahead and take the natural log of both sides. So the natural log of 2 equals, these two are inverses, 4r. Divide both sides by 4. Natural log of 2 divided by 4 gives you r. And again, since it is possible that somebody punched this in wrong and that's the reason that they're not getting this correct, I'm going to go ahead and do this on the smartboard calculator here. And we see there that we have the interest rate. And we couldn't do the second part of this unless we had the interest rate. So that's the whole reason that we needed to find that. So the interest rate is approximately 17.329%. Now we go back to the formula and realize that this is going to be 0.17329. Well, that doesn't even look anything like that. Try to write a little bigger here. Let's see, 0.17329 T. So now, we filled in the first blank that they had there, the first question about the interest. Now they wanted to know how much will be in that account after 15 years. And then this just becomes really basic because we know they started with 9,500 and we have our 0.17329 and we just need to take that times 15. So again, you can do it in pieces. Second e to the, and I already have that as part of my answer up there, so second answer, and then we needed that times 15. We get an answer and we take that times the $9,500. And there it is, $127,816 and about 26 cents. So that would be how much in 15 years. So you need that interest rate first in order to figure out what's going on with the account, how that interest is accumulating. 36, this one says complete the table about doubling time on an investment. And this one has an 8% APR, but it's quarterly. So different formula there. If we have quarterly, we want to use this formula. And what we want to know is, when is this going to be doubled? And you look around and say, wait a minute, I don't have any values for that. Well, you could just as easily say, I want $2, I'm starting with 1. Because what's going to happen is exactly what happened with all of the questions before when we did doubling. If we divide both sides by 1, we're going to get 2. And then we just put in the information that we know and find what we want. They wanted to know what time it's going to take for this to double. So let's start putting some information in here. So 2 equals 1 plus, well, the interest rate is 8%, but this is not annual interest, it's quarterly. And we need to know what T is. So now, let's go after it and see if we can get an answer. Well, we need access to that t, and right now it's an exponent. So what we will have to do is take the natural log of both sides. Natural log of 2 equals the natural log of 1 plus 0.08 over 4 to the 4t. Now we can go ahead and bring that 4t out in front. And we will have the natural log of 2 equals the 4t times natural log of 1 plus 0.08 divided by 4. Now this one is kind of nice because we can go ahead and simplify what we have in the parentheses. It's certainly not difficult to simplify 0.08 divided by 4 and get 0.02. So this is 1.02. And you get to this point and you say, well, now what? Well, remember, we're still trying to get t all by itself. And the 4 and the natural log of 1.02 are just being multiplied times everything. So to get rid of that, we're going to divide. This is gone. So again, we just have to be careful punching everything in and make sure that we use parentheses. So our calculator knows everything that's going to go on, unless you wanted to do it in parts, which you also could do. So we need the natural log of 2, getting that answer, and I'm going to divide it by all of this, 4 natural log of 1.02. And finish off those parentheses so the calculator knows divide it by all of that. And we have about 8.751 years, which, as we talked about in class, normally they will not pay that out until you have completed that full year. So 9 years for that compound interest to get to be what you want. It'll be a little more than you wanted, but that's okay. It just can't be less. So 9 years. Then number 40, we have this one compounded continuously. So that's Apert, Sinky Green Shampoo formula. Again, we can just go with $2 and $1. Pretty basic way to think of it. And for number 40, since this is compounded continuously, we have this little 0.07 that we can put into the formula. And then we just take the natural log of both sides. And we notice, hey, we're always getting the natural log of 2. Of course we are. We're doubling. That's what's happening here. So natural log and e are inverses of each other. And then you just divide both sides by 0.07. So let's see what we get. Natural log of 2. And we need to divide that by 0.07. So we have 9.902 years. Which this was compounded continuously. And with that, again, the only people that are going to get that are people with a lot of money. So they might have it written in the contract that they can go ahead and pull it out at 9.902 years and get what they wanted out of it. But for the majority of this, we'd say we're going to need to round that up. Because inherently in any account involving savings or paying it off, everything has to do with the end of the year, meaning that contractual debt for that last portion of the year. And that was everything that you would ask for.